Okay, hey there, we are going to make quick little videos on the key elements of Chapter 9 so that you have this for review and you know it for things like next year in IM3. In 9.1 we're talking about polynomials. Poly means many and nom is really like name or term, and so we have a many term, or at least potentially many terms. It says in the book, you can read the definition, that it's the sum or one or more, so it could be a sum of just one, but one or more direct variation terms, or terms where the exponent is a whole number. So for instance, if I said y equals 3x to the 7th, that's just a single termed polynomial. I could add other terms, 4x to the 5th plus 12. This is even a term where the exponent is 0. So whole number exponents. These cannot be negative exponents. They cannot be decimal exponents. So we can't have square roots. So things that are not polynomials. Y equals the square root of x. Y equals 3x to the negative 5. You're allowed to have weird things out in front. Y equals the square root of 3 times x to the 5th would be okay, but if I write 1.5, that's not okay. So those are all things that are no good. I could say square root of 2 pi x to the 3rd. That's okay. It's okay to have weird numbers out in front. It's just not okay to have weirdness in the exponents. So y equals the absolute value of x. Y equals 2 to the x. These are things that are not polynomials. It has to be something in the form of a constant like a x to the n, where that is a whole number. Okay? So here's a potential polynomial, and I'm going to want you to write it in standard form. Standard form, we always write these individual terms so that this number is going down. It can skip between 7 and 5. There can be a missing 6. You can have nothing all the way down to the x to the 0, or just the constant term it's called. But you want to put it in order by this exponent. This is called, the highest exponent is called the degree. Okay? So this would be degree 3. This would be degree 7. If that term didn't exist, we'd say that's a 5th degree polynomial. Okay? If there was nothing there, we'd say that's just a constant term, or you could say degree 0. That's not used very often, but typically we'll say 1st, 2nd, 3rd degree polynomials. Alright, so try this. Y equals 5 times x minus 2 times 3x squared minus 2x plus 1. Alright, so if you were to write this in standard term, there's a homework problem that's similar to that. Pause the camera and then let's see what it is. But write that in standard polynomial form. Highest degree to lowest, all cleaned up. Okay, you pause me, we're going to come back and do that. Well, if I multiply this in like that, I get 5x minus 10. And then if I'm going to multiply it by 3x squared minus 2x plus 1, I just have to very carefully distribute this in, and I'll get negative 30x squared minus plus 20x minus 10, and then I'm going to multiply this 5x into each of these, and I will get then 15x to the 3rd, and then I will get negative 10x squared minus 10x squared. You notice I'm lining these up so that the degree matches, and then I'm going to get plus 5x. So my final best answer would be 15x to the 3rd minus 40x squared, and then plus 25x minus 10. And that would be in standard polynomial form, a degree of 3. A lead coefficient, that first number there, is called a lead coefficient. You should know all of these terms. I-E-N-T, coefficient, I-C-I-E-N-T. Lead coefficient is the first term. Still can't spell. All right. Good luck.